right, so today we're going to use the synthetic division we talked about yesterday to use two separate theorems. So this is going to be 5.8, the remainder and factor theorems. All right, so I'm going to start off with this warm up and see if we can figure out the remainder theorem just on our own. So the warm up says to consider the polynomial function f of x is x cubed plus 9x squared plus 22x minus 1. And we're going to find f of -1. So what does that mean? Like, what are they telling you to do if they're asking you to find f of -1? What do we do with that -1? Plug it in for x. Okay. And then we would just take our graphing calculator and we would plug it in just like I wrote it. Okay, so we get -15. Okay, so over beside it, we are going to use synthetic division and we're going to divide that function by x plus 1. So what will we put in the box? -1. All right, and then as I look at my terms, nothing was skipped. So it went from 3 to 2 to 1 to none. So I would just bring over my coefficients and my constant and leave a space, draw a line. So that first number to the right of the box drops down. And then we start multiplying and adding. So you multiply the number in the box by the number under the line, and we're going to get -1. And you add, and you're going to get 8. Then you do it again. The number in the box multiply by the number under the line, and we get -8. And we add, and we get 14. All right, one more time. Box, line, that's -14. And we add, and we get -15. Could be a coincidence. Could be a theorem that these are the same. So we're going to try it again with another function. Now, if it works twice with two different functions and two different numbers, it's probably significant. All right, so we are going to plug in 4. So we have a brand new function. we get 23. All right, so if we're going to divide by x minus 4, that's going to be a positive 4 in the box. Do I need to fill in any zeros on this sign? Was anything skipped? Yeah. So we need to fill in a 0x cubed. All right, so the 2 drops down, and then we just start multiplying these two together. That's 8. We add, we get 8. And then we multiply. We add and we get 2. And then multiply, get 8. We add and we get 10. And then multiply 4 times 10, 40. I don't know what I just did. There we go, 40. And we add and we get 23. So somebody who was brilliant a long time ago, before there were calculators at all, figured this out. And this, if you can't have a calculator, doing it this way is way faster than doing it this way. Because you would have had to raise 4 to the 4th power, which is something huge, multiply that by 2, raise 4 to the 2nd power, multiply that 30. If you were doing all this by hand, that would take forever. Doing it without a calculator here, like I didn't touch a calculator, you guys probably didn't either, it's way faster. So at one point in time, this was like a real big time saver to do this with synthetic division instead of just actually plugging it in. Now, part of your EOC is without a calculator, just like it was in geometry. So it's possible there would be a question like this on that part of the EOC because you can do it without a calculator easily. Okay. So what we just figured out was the remainder theorem. So the official theorem says something like if a polynomial function f of x is divided by x minus a, so x minus something, then the remainder is f of a. So anytime you use synthetic division to evaluate a function, it's called synthetic substitution. Now, one thing that we talked a lot about yesterday was that whenever you're doing synthetic division, you're going to put the opposite in the box. You remember me saying that a lot? Well, if you look at this synthetic substitution, did I put the opposite in the box of the number I was trying to simplify or to evaluate? I did not do the opposite. We were just looking at -1, -1, 4, 4. So this is one time that when you're doing synthetic division, you don't do the opposite. You actually use the number. All right, so for number 3, we're going to do synthetic substitution or use the remainder theorem to find it. So if I want to find f of 5, I actually put 5 in the box. Do I need to fill in any zeros on number 3? Nope. So that's going to be 1, -13, 39, -4. Bring down the 1 and then just start multiplying and adding. Right, so if we're evaluating functions, we're doing synthetic substitution. The only thing we care about right now is the remainder. So f of 5 should be equal to -9. Now, a lot of times if I'm like doing like a synthetic division problem real fast and I want to know if I did it right, I just check the remainder. Like I'll plug it in the calculator and make sure I got the right remainder. All right, let's look at number 4. So we're going to do synthetic substitution to find f of 10. So that means I'm going to put 10 in the box. Do I need to fill in a 0? Yes. I need to fill in a 0 for x. So I'll bring down the 1 and then just start multiplying and adding. It's fun to do it when you get a bunch of zeros. It's super easy to multiply by 0. So out of all these numbers, the only one we care about, if we want to find f of 10, is the remainder. So f of 10 should just be negative 4. Okay. Then we are going to do an application. A lot of times application problems make people nervous, but it's, I promise you, not any more difficult. Maybe the numbers get a little bit bigger, but we're going to do the exact same thing we just did. So on this application, a bicycle manufacturer determines that the profit per bicycle when producing X bicycles per day is given by this function, P of X. And we're going to use the remainder theorem to find the profit by bicycle when 4, or it should be per bicycle, sorry. No? Profit by, I don't know. When 4 bicycles are produced each day. So what do you guys think? We want to find the value of this function when it's 4 bicycles. So what are we going to put in the box? Not negative. Actual 4. So on each of these, when we're doing this synthetic substitution, you actually use the number. All right. Now this one we do have to fill in a 0. We're going to put in a 0 at the very, very end because there wasn't a constant number. Okay, so we'll bring down that negative 1 and then just start multiplying and adding. Now 4 times 29 might not be one you can do quickly in your head. Okay, so again, the only thing we care about for this bicycle situation is 116. So if they produced 4 bicycles each day, they would make they would profit $116 per day. All right, any questions on that? So synthetic substitution, use the number, and the only thing you care about is the remainder. Okay, the other theorem we're going to talk about today is the factor theorem. And this isn't the official theorem, this is just what I said the theorem was. So theorems are usually worded in a way that's really hard to understand. But if a polynomial function f of x is divided by a factor, the remainder is 0. Now I know this has the F word in it, factor. You're not going to have to factor. So all we're going to do is synthetic division, and we are going to determine if it's a factor just by looking at the remainder. If it goes evenly, the remainder is 0, it's a factor. All right, so this, we're going back to what we knew yesterday. If it's given to you this way, x minus 4, we're going to do the opposite. So 4 would go in the box. Do I need to fill in any zeros? Was any turn skipped? Nope. So it's going to be 1, negative 16, 48. So what we're doing when we're deciding yes or no, is this a factor? We're just going to do synthetic division and see if we get a remainder of 0. If we do get a remainder of 0 like we did, then we're just going to say yes. The answer is yes. X minus 4 is a factor. So let's do that for x minus 8. X plus 8. All right, so it's written this way as a factor. We're going to make sure we do the opposite. So it's negative 8 we're going to put in the box. I'm going to make sure I fill in a 0 for x squared, so be careful. Okay, so I'm going to bring down that 1, and then I'm going to start multiplying and adding. Now these get kind of big kind of fast. Okay. If we get a remainder of anything other than 0, we are going to say no. It's not a factor. All right, you guys try 8 on your own, please. Okay, so 3 times 52 is 156. So we get a remainder of 0. So we would just say yes. Okay. All right, and then I'm going to do 9 with you, mainly because there's a bunch of zeros to fill in. I just don't want you to miss something. All right, so we put negative 6 in the box. Now don't forget, nothing can be skipped. So this one went straight from x cubed to no x's. So skip the x squared and also skip the x. So we would do 1 for the x cubed, 0, 0, 216. All right, so we'll multiply negative 6 times 1 is negative 6. And then we'll add. And then we'll multiply. And then we'll add. And then we'll multiply. Remainder 0. So it's going to be yes. All right. What questions do you guys have? Okay, so just remember, I know it's a lot to keep straight, but if what you're dividing by looks like this, like x plus 6, you do the opposite. X minus 3, you do the opposite. If instead you're being asked to find f of 5, you just use that number. F of 10, you just use that number. All right. So your assignment, I'm about to give you the Unit 5 Homework 8 worksheet. It has 8 problems on it. And then I also want you to do these 4 because the worksheet doesn't have the factor theorem on it. So these, you're just deciding yes or no. So they're like what we just did. And I put the answers on the board. But for you to get like if you just wrote these answers down, just like yesterday, if you just wrote the answers down, you get no credit. But if you have to show where you're doing the synthetic